Have you ever solved the GMAT question, found a value that works perfectly, and still ended up with the wrong answer? That can happen because of one very quiet GMAT trap, hidden integer constraints. This trap doesn't break your math, it breaks your logic, and it shows frequently in data sufficiency questions. Hi, I'm Andrea Madeira, and my focus is helping students make better decisions under GMAT time pressure. So hidden integer constraints appear when a variable must be an integer, but the GMAT doesn't shout it out. Instead, the constraint is just implied by context, embedded in wording, or revealed only if you pause and think. So on the GMAT, a value that works mathematically is useless if it violates the logic of the problem. This trap causes two major problems. The first one, you accept values that shouldn't be allowed, like fractions, negatives, or even decimals. And in second place, you misjudge sufficiency. You think a statement works, and initially value ruins it. This is one of the mistakes that can make strong students miss data sufficiency questions. But let's look at a real GMAT-style data sufficiency example to elucidate this trap. So our question is asking us in how many ways can n students be seated in a row with n seats. So if you notice, this is a combinatorics example where we have the number of objects equal to the number of places. So in this particular situation, to solve the exercise, you just need to do n factorial. So to solve this exercise, sufficiency comes from the fact that you know the value of n. But before we even read the statements, something matters a lot here. N represents the number of students, and that immediately tells us that n must be a positive integer. So let's now analyze each statement. So on the first one, we know that absolute value of n minus 12 is equal to 5. So let's solve this. So we know that when we have an absolute value, we need to say that n minus 12 is equal to 5 or n minus 12 is equal to minus 5. So from here, we take that n is going to give us 17 or n is going to give us 7. So from here, we take two values of n. And if we substitute here, the two values is going to give us two different results. So that means that statement 1 is not sufficient alone. Now let's look at statement 2. So here we have a second degree equation. Let's rewrite this. So we have n squared minus 4n minus 221 is equal to 0. So the first thing that may come to your mind here is, okay, if I solve this, I would have two different solutions. And if I have two different solutions, that's going to lead us to the same reasoning as before. So we don't have sufficiency here. Careful, because mathematically both solutions may work, but logically maybe one of them is impossible. Let me show you. To solve the second degree equation, we know that we need to find two factors that multiplied by each other are going to give us 0. So now we first write the variable, and now you know that you need to find two factors to put here that multiplied by each other is going to give us minus 221, and two factors that added to each other is going to give us minus 4. So we know that we need to have minus 17 and plus 13 here. So minus 17 times 13 is going to give us minus 221, and those two numbers added is giving us minus 4. So now we know that n is going to give us 17 or n is minus 13. But you cannot have minus 13 students, right? Once you enforce the integer and positive constraint, only 17 remains. That gives a single value of n and a single number of seating arrangements. So statement 2 is in fact sufficient, and your answer choice would be B and not C. So in this case, we need to say that statement 2 is sufficient because only one value of n is enough. To answer the question, the only valid one is going to be 17. So that means that our answer choice is in fact B. So statement 2 alone is sufficient, but 1 alone is not sufficient. So this is the core lesson of hidden integer constraints. Always ask what values are actually allowed, not just what values solve the equation. Is the variable a count? Can it be 0? Can it be negative? Can it be fractional? If the context implies an integer, you must enforce it. So the GMAT knows many students trust algebra blindly, so it gives you equations that technically work, but logically don't. So top scorers don't just solve equations, they polish them. So if you've missed questions like this before, it doesn't mean you don't understand data sufficiency. It means, in fact, that the GMAT caught you relaxing a constraint you shouldn't have. And once you build the habit of checking constraints, this trap almost disappears. So I post one focused GMAT strategy video each week. So subscribe if that would be useful for your prep. I will see you very soon.